Hello explorers and welcome to another video. I'm Daniel Persson and today we are going to talk about Java build systems or build tools, and we are going to compare Ant, Gradle and Maven. So let's jump over to the code here and look at the first example, and that's Ant. And in this whole tutorial I will use the source main Java org EA structure with my lift guide Java. So that is a structure that you usually use in Maven to structure your project in order to put your main Java classes, your test Java classes, and your resources in specific directories. Some of the tooling requires these directories, some of them don't. So the first example we're going to talk about is Ant. And Ant is the first of these tools. It's the one that has been here for the longest, and it has a little bit of a legacy, but it's very simple in its constructions. It's a bunch of tasks that requires other tasks. So if we go on to the first here, we have a project. And this project is in a build XML. So Ant requires a build XML where you put your project definition. And here we have a new namespace for Ivy, and we're going to use a tool called Ivy for all our dependencies, so we can download those from the Maven repository. And this is a tool that is not a part of Ant, because Ant didn't really have any dependency tree from the beginning. This is something that we have ad hoc afterwards. And actually Ant didn't really have that much of a library structure or anything from the beginning. It was just to build different Java files or Java classes and so on, and build them to cohesive projects. And then we have this name of our project. I just call it the build tool project. And default is the default task to run, and I will call this main in this example. Then we have our base directory, and this is the current directory, and a little bit of a description about this little project. Then we give this a project name, and that will be used when we are building things. So the jar file will get this name. We have a source directory, and this is the structure that I talked about, source main Java. And then we have a bin directory where it will build all the classes to. We have a dist directory, and that's where we will create our distribution into. We have a dist lib, and there's where our libraries from the dependencies will be. And we have a library directory, and that is if we are not distributing, we will put the libraries in there for building things beforehand. And we have a main class, and this is org AI lift guide. Then we have the configuration for Ivy, and this is to download Ivy and install it on our computer, because this is a separate library. So it will first off make the directory in our Ant, in our home directory ant lib, and then in the home directory .antlib it will put the Ivy jar, and that will be downloaded from this remote Maven repository, and we will get the 2.5.0 release candidate 1, and that's the latest version of Ivy. And actually in the guide that I found on this, it said 2.4.0, and that didn't really work out of the box, so I changed it to the latest, and that seems to work better for me. Then we have this target here, resolve, and that's a separate target. Something we can do, we can run a resolve, and that will go out and fetch our dependencies. And those dependencies are defined in a separate file. This is the Ivy XML that you see here. This is an Ivy module. We have some information about this Ivy module. I haven't really changed these. Doesn't really matter for the download. And then you have a dependency declaration here where I want to have the org Apache PDF box, and the PDF box version 2.0.19. So that's the version I want to download and run in my project. And we are going to create a PDF in this project. And then we have this initialization target, it will just create my build directory. We have a class path where we put all the jar files from the lib directory into our class path. We have a target where we compile, and this compile target requires the init target. So it requires that this directory is present in our system before it can run this compile. And we can also have a description on our target. This will run the Java compiler with the with not including the Ant runtime, because we don't really need it for this build. And the source directory will be used here. The destination directory will be our build directory. And then we have this class path reference to the class path we have defined above. We also need to copy all of the dependencies into one big dependency jars if we have multiple of them. So this little copy script here will create this dist lib directory, and then we'll create a new jar file with all the dependencies in that jar file from the zip group set. That's the jar file group set, because all jar files are actually just zip files. And it will then pick up all the jars in the include directory, in this lib directory. So this will copy everything over to one big jar file. And then we will have this target called jar, which will compile and copy dependencies. So that's the dependencies of this jar target. So if we just run jar, it will run this specific target. And that will make the two directories required. And then it will build a jar file of the current project name with this directory and do that into the build directory. It will use the manifest and set the main class, create a manifest, and the main class therein will be the main class that we want to run, our org EA lift guide. And then it will also zip into that directory the specific dependencies all jar. So it will add that dependencies, but it will remove the meta-inf SF files, because those will be included by our build and can be very destructive for our process, because we will get the wrong ones there. So we will exclude those but copy the rest in. And then we have a target here that's called clean. It will remove our build and the dist directory. And the last main target we see down here, it will run clean, compile, and jar. So that brings everything together. So if we just run ant in this directory, it should run all of these targets. So we go over here to our build guide directory. And in my tools directory, I have ant installed. Let's see, Apache Ant. Bin ant. So if I just run ant, that means run my main task. Actually, we can't do that because we haven't run. We need to run a few commands before that. First off, we need to run ivy to install ivy in our ant directory. I believe I've already done this. This should be really fast. Then I need to do resolve. And that is required the first time you build in order to go out and download the dependencies that are required for our project. And if we go in here and look in our lib directory, you see you have a lot of different libraries now downloaded for this specific project. So we only asked for PDF box 2.0.19, but the script here, ivy, saw that a lot of other things were required too. And when we have done that, we can run just the ant command, and that will go through and actually build our directory, compile everything into the bin directory, create our dist directory with the libraries, create this dependency all jar, and then it will create our build tool guide jar file. And when that's successful, we can run this and actually create our little script or our PDF. I will not run this now, but it works. This is one thing that we can run later. Next up, we want to look into Maven. And Maven, as we came from this ant, where you had different targets that did different things. You could call these targets whatever you want, and you can structure them however you wanted. And Maven is a little bit an answer to that, where somebody sat down and thought this through and came up with that you actually in the build process have a specific set of steps that is required to make a product. You need to build something. You need to test that thing. You need to package that thing. You need to release that thing. So they actually figured out a few different phases of product development that were required to make some product. So this is very much more structured, and this file for Maven is called POM XML. And in this project model, you will add first off some dependencies or some namespaces up here. You will have a model version. I've always run with model version 4. I haven't seen any earlier versions or any later versions. There might be a model 5 someday. I haven't seen that yet. And then we have our group ID, and this should actually be EA. So org EA, build tool guide is our artifact ID. So that's the name of this specific package. So org EA, it's the grouping. So if we had a company, for instance, Apache, that would be org Apache, and that they have everything that they build into that, and then they have different artifacts in that. And then you have a version. In this case, it's 0.0.1 snapshot. And the interesting thing here is when you create a snapshot, that is not a build. And if you release something, it will create a specific release version, and then it will create the next snapshot for you, so you can actually follow the process through. And if you have built a snapshot, you know that that is not a released version. It's something that is changing. But when you are releasing something, creating a release version, that should be something that is tagged and frozen in time, so you can actually go back and build that version again. Next up, we have the properties that we want to put in here. I usually say that I want a specific compiler target, 1.8 I use usually. And then we have an encoding here, UTF-8, and we will set that for a lot of different things, the source encoding and the output encoding, resource encoding, and the archetype encoding. Then I will put up an SCM, so source control management. And this is just GitHub. And this is the specific place you can find this code on GitHub, github.com, classbuffer, build tools guide. I will put that in the description as well. But if I have this SCM put in here and also use the release plugin, I can actually just create releases. They will be tagged, put on GitHub, and then I can download and build them again, or find out what specific function were in a specific build. Next up, we have our dependencies. And in this case, we just have this Apache PDF box. And then we have some build steps. And in this build here, we have some plugins. And these plugins are the assembly plugin. That is what puts everything into one jar file. And we say what version we will use that. So we actually define the group ID, artifact ID, and version for all dependencies, for all plugins. So it's the same structure for everything. Then it can have some configuration. In this configuration, we will just say what we want to do with the specific entries in our manifest and what our main class will be. So this is that short configuration here. Then we can have a descriptor reference that I will put on the specific assembly class. So I know that this is a jar file with all the dependencies. So the name of the jar file will actually be the build tool, what would you call it? Build tool guide dash 0.0.1 dash snapshot dash jar with the jar dash with dash dependencies dot jar. So that's the full name of this. It's very structured, but it's very verbose as well. And next up, we have some executions here. So we say that this will run in the goal single. So we will create something single. So we can say that we just want to make an assembly single. But we also say that this specific goal is run in the phase package. So if I say that I want to package something, it should also run this specific plugin. And all the phases can be found on the Maven repository. You have some pre-build tools, some pre-compile tools, you have some compile phases, and so on. So there's a lot of different phases, but they are in order. So it's good to figure out where in the process you want to put your plugin. And there are a lot of guides out there, and all of them are exactly the same because you only have one way to make this project. And then we have the release, and the release project here, or plugin. We will not look at this in this specific tutorial. I just wanted to add it here so you see that you can have other goals. For instance, here we see that the pre-integration test, so that's another phase that we will run this release in. And preparation goals are packaged, so it requires to have a package already. And we put in some timestamps into our snapshots, and we also have a specific name format for our tags. So just to show you that you can put in plugins in different places or different phases of your build. So in order to run this, when everything is set up to create our build, we only need to run nvm like Maven and then package. And that will run this specific Maven build. It will look in this POM file for all our dependencies, go out to the internet and fetch these dependencies and then build our tool. One caveat here is that we actually have a Maven repository local on our machine in our home directory M2, and then a lot of other caching things there. So if you're downloading some dependencies, it will be linked from there, and we only downloaded once. That means that you don't have to wait for a lot of different things to download every time, so the build should be generally faster. And if we look at the last thing here, we can look at the Gradle. So this is the last definition. And Gradle is a little bit of a step back from the very structured way of Maven. And they took some things that they thought were good from Maven and then threw a lot of other things away because they thought that Maven was a little bit too strict. They wanted to go back a little bit more to Ant, but keep all the dependencies and so on. And they also wanted to remove XML and write less. So in this little Gradle script here, you have to apply the plugin Java. You can actually build a lot of different languages with Gradle. Then you have the version number, you have the source and target compatibility. Those are the Java versions that you want to run. Then I create a task here, fat jar, and of type jar. And then we define the manifest. So this is the manifest things here. So implementation title, implementation version. So this is the version we had up here, and our main class. So this is pretty similar to the Maven dependencies. Then we will create a base name for the actual output, and this will be the product name -all. And then we will don't really know what this thing here is. Is it to collect where to compile things and zip everything into one jar, and then you use the plugin jar here in order to compile everything. So this is a very more terse way to write the same thing we did in Maven. A little bit harder to read, but then again, I haven't run that many Gradle scripts, so I'm a little bit biased against Maven. Then we have repositories, and this is very good here because you can actually say that you want to use Maven Central, you can use Maven Local, you can use other defined or define your own repositories in order to say where you want your packages to come from. And then you have a set of packages that you want to have, and they can be in different stages. So here we say that we want this to be during the compile phase, so it will always be in our package. But we can also say that we want it to be in the implementation tests phase, and that means that it will only be run during tests and never be in the final product. And here we say that we want our PDF box again. So let's go back here and look up Gradle. That should be in tools as well. Gradle, bin Gradle. I think we can run it like that. No, we want to run Gradle and the task, of course, fat jar. So there we need to define what task we want to run. In Gradle, there is actually a command called task, where it will print all the defined tasks in your project. And there you see a lot of different tasks that you can run. So there it contains a lot of different tasks. We can look into that as well. But I didn't really see fat jar in that description. And now we see it compiles, and now it runs the fat jar, and there it's done. So if we run task here, we will get a list of all the tasks that we can run, and all the green ones are the things we can run, but I didn't see the actual fat jar here. We have a jar which assembles jar archives. So I'm not sure if we are missing something or something like that. If we go into this little explorer here, we can look into I have a lot of projects here, build tool guide over here, and let's look at the distribution directory. So here we see that our Ant dist were 16 megabytes of jar file. So it was a lot of libraries, and these libraries all were 17, so it was actually larger than the final build. If we go into our let's see, build directory, libs. So this is the final jar from Gradle. It's 4 megabytes, 4.3, called build tool guide all, and then the version number. And if we go into the target directory here, we see where Maven put it. So this is the build tool guide 0.0.1 snapshot jar with dependencies, and it's also 4.3 megabytes. So both Gradle and Maven creates a lot less of an impact in size. Then again, it doesn't really matter because these projects aren't that large. But Ant is that plugin that is separate to the build process can't really figure out what's required to build your project as well as a built-in project that is actually built in order to create this specific packaging. So in both Gradle and in Maven, this were thought about while they created this, and the build process of adding dependencies with Ivy is something that they put in later. So this was my little bit of a comparison between these different toolings. Ant is the old one, which can be used to package your things if we want to build a very specific structure with a lot of different tasks. Then it can be very simple to use that one. Maven is this one very structured way of building programs that you can use in order to create a good structured way of getting product out there. And if you are able to put in things in the right phases, you know that you follow a good structure and well thought out structure. Or you can go the Gradle way, where you write a little bit less, a little bit terser, and you can actually write both different tasks that does a lot of work for you, but you also have the power of the Maven repositories for handling your dependencies while building your Java programs. So what did we actually build in all of these examples here? We built this little lift guide. And this is a project where we set a bunch of font sizes that can be different font sizes. We create a document, a page. We set some text in this project. We write out some text and then close this and save this PDF. And the PDF that we have built today is this PDF with "Don't Panic" with large red friendly letters from the Lifter's Guide to the Galaxy, where the book actually had this phrasing on the front cover in large red friendly letters. I hope that you found this video interesting. I hope that you learned something today. If you have any questions or suggestions, leave them down in the comments section down below. If you like this video, give it a like, share it with your friends and colleagues. If you haven't subscribed yet, please do that. And I really hope to see you in the next video.